There are a lot of extremely interesting topics in second semester physics. We probably begin the course with the study of fluids, things like pressure and Archimedes' principle, buoyancy, and then some of the dynamics of fluids that are really just expressions of the conservation of energy. Bernoulli's equation, which relates pressure, velocity, and altitude of a fluid. Had to think all the way back to conservation of energy to come up with that one. It's a little late in the evening. We answer questions like, why are submarines crushed when they go to great depth? Why does the pressure at a great depth push in on the sides as well as the top and the bottom of the submarine? Again, why are things buoyant? How does buoyancy relate to pressure? Okay, what's the source of atmospheric pressure? Where does atmospheric pressure come from? What is it? What does it mean? How does an airplane fly? How does it stay up in the air? What is it that gives it the force, or what is it that provides the force to keep the airplane from being pulled down to earth by gravity? Why does the airplane have to be moving to stay up? We all have an intuitive notion of that, of the lift that you get from a wing and so forth, but what's the actual physics behind it? And how does that actually come out of conservation of energy? What happens if we have a glass full of water and we poke a hole in the side of the glass? How does the water flow out? How do we determine the depth versus time for the water? Okay, then we study gases, the relation between pressure and volume in a gas. If you have a gas at a constant temperature in a closed system, if you compress it down, we're all familiar with the idea that pressure goes up. If we pump more gas into a confined area, or confined container of constant volume, let's say, the more air we pump in, the greater pressure. If we increase the temperature of a confined gas, that increases the pressure. Why do these things happen? What are the relationships, and what good do those relationships do us? Where does the pressure in a gas come from, and how is that related to energy transfers in the gas, and so forth? Okay, how can we use a billiard ball model to obtain the relationship between pressure and temperature and amount of gas and volume of the gas? What are these relationships? This moves us into the ideas of thermodynamics. If we have a source of thermal energy, be it gasoline being sprayed into the combustion chamber in an engine or into a piston, into a cylinder and exploded, or temperature gradients within the ocean where we're using essentially solar energy or geothermal sources of energy. How can we convert thermal energy to useful work? How much of the energy can we convert? What are our restrictions? How do we design things in order to take, how do we design engines in order to take advantage of those types of sources of energy? It's very important ideas. How do we get useful work out of different energy sources? That's the study of thermodynamics. Other questions related to these ideas. Why can't we set a refrigerator in the middle of the room, open the doors, and cool off the room? What makes heat pumps so great? Aren't we using electricity, and isn't electricity an expensive form of energy? Well, yes it is, but the electricity, the energy that we use in the electricity is actually less than the heat that the electricity manages to pump from the cooler air into the warmer place. How does that happen? How do we pump thermal energy from something that's cooler into something that's warmer? And why will the universe eventually run down? Why do things move from a state of order to a state of disorder? Why is it that when we have temperature differences, they tend to modify, they tend to come to an equilibrium? And what are the implications for the life of the universe? And what are the implications, again, for heat engines?